Thank you for returning and being part of our series, Dr. Emanuel series on engineering mathematics. We're now doing lecture number 22, Spherical Coordinates, part 2. We've been looking at polar, cylindrical, and spherical. So let's take a look at each one again and look at them in more detail and see them side by side. So here we have in the XY plane, we can graph this using X, our rectangular coordinates, or our polar coordinates. And our X and Y, we just have our rectangular coordinates. Go over X and up Y. Very simple. Then when we come to this polar, we're now looking at the angle that we have here. So if we take this angle and the radius, those are the only two things that we need to be able to define a point in polar. Just like the X and Y, it's R and theta. R and then theta. So d theta is the change in theta, that angle. dr is the length that has changed. And our arc here, we can see that we have d theta. d theta, if we look at this as a right angle, as it is tangential to the circle. If we have our plane tangential to the plane, then what we can actually come up with is the sine of theta times r will give us this arc. And for a very small theta, sine of theta and theta are equal, basically. And so we can use r d theta for this arc here. Now when we want to go to cylindrical, like cylinder, we had another part which is what we call z. Now we have 3 dimensions. Here on the bottom we have our 2 dimensions, which is the same as our circle here. And we use theta here. And here was our d theta. And then here was our r, radius. And this is our r times d theta. And if we take this arch and we go up z, we have a change of dz here. So to find the volume, we need the length times width times height. So what we have here is we have dz as our height. We have here dr, and then we have here our r d theta. Now, if that wasn't complicated enough, we decide we better give you another dimension. And so now we'll go to spherical. Okay, so we explained 2 sets. So now we're just going to add to this one. Okay, phi. Okay, so that's what's going to be added. So we can use phi and theta interchangeably, as you can see, which they do. So what we will have here is, as you can see, we're just going to add another component here to take in this dimension. See that d theta here. Okay, we already defined r dr. We already defined r d theta. We have here, we define dr, we define d theta. Okay, it's the same thing, it's just moved up here, showing you where the z comes in. So we have now r times the sine of theta d phi. So if you use this r times the sine of theta, you get this line here, opposite. Okay, remember these are all at 90 degrees tangential to the curve, the circle. And so now that you have r sine of theta, now you're just going to take d theta as that changes. D phi. Sorry. Okay, so let's look at some of the equations. For polar, let's see. Okay, so for polar we have x squared plus y squared equals r squared, which is very simple. Okay. Basically Pythagoras theorems, they call it. And we have cylindrical. What are we going to replace x with? We're going to replace with r times the cosine of theta. And then what we're going to be able to do, replace our y with r times the sine of theta. This is just using the right-hand rule. That's all it is. Very simple. And then we're going to find what the volume is, and the volume is, and our z is just basically our z. Our volume is equal to r d theta, which we have here. Remember the volume is equal to base times height times width, 3 dimensions. So if we use this r d theta as our width, as our length, we can use dr, and as our height we use dz. Okay, so here we have in our little cubic volume. Now when we look at, if that wasn't enough, we go to spherical. We want to make sure that you can walk away with, having your, knowing that lots of stuff to be done. So we are now going to change x. And as you can see, our x, y, and z all change. Things are added to it. Okay, now we change the angle from theta to phi down here, and then theta we're using up here. So, when we look at this, we can see that the only thing that's added is this third dimension of how this is looking here. It's the only thing that's added, our d theta. Okay, so this is what we would say r times the sine of theta gives us this line here, okay, times d phi, which is this angle, which we use here. So now we have, instead of dz, we're going to be using r times sine of theta d phi. So that's what we'll be using as our other component. Okay, so now we have z is equal to r times the cosine of theta. You have theta here. This is the sine of theta, and this is z, the cosine of theta of r. So it gives us this angle here, this side here, our z component. Our y is our r times the sine, which would be this line here, okay, times the sine of phi. And that will give us this side. Then we have x is equal to our r times the sine of theta, just like the x was. But now we're doing the cosine of phi, not the sine of phi. The cosine of phi, which is down here. So our volume changes to r squared times sine of theta, dr d theta d phi. We'll look at it another way, again, for a sphere. Okay, we looked at the polar. We saw our differences between our polar and our spherical. Aha! See, now this is what changes our sphere. Now we look at it like a globe. This is still this part as we look down onto it from our x, y position. Now we have here a few number of points. Okay, we have our phi, our theta, our r, our z, our x, and our y. So, we found out that polar is x squared plus y squared equals r squared. We found out that also that our cylindrical is x times r equals x equals r times the cosine. We found out that the y is r times the sine, and z is just z. So our volume was, as you can see here, if you look at it from this vantage point, you can see the change as it occurs in this area. So, this is our volume, same as we had before, just a little more clearer definitions, or closer. And as you can see, this is spherical, and you can see that we have, as it goes around like the equator, and like latitudes, and this here will be like a longitude, okay, on our globe of what we will be examining. So let's look at the Cartesian and spherical coordinate system for the moment. Okay, we're going to first always need to calculate the relationship between the Cartesian coordinate system, okay, which we'll be looking at down here, and our spherical coordinate system. As we go from x, y, and z of the point P, we have here, in its spherical coordinates to rho, theta, and phi, using trigonometry. So we're going to come back to this, and we'll take a break. We're at around 13, 14, 15 minutes. So we'll come back to this in a minute.